Hello friends, you are all welcome to this channel, Government Ghosh channel. Kindly subscribe the channel. Hello friends, today we discuss about the solution of exercise 1.1 of relation function. So question number 1. So we have to show the following relation are reflexive, symmetric and transitive. So question number 1 I. In this case, you see R is a relation in set A which contains 1, 2, 3 up to 14, and which relation defined as R equal to x, y order pair such that 3x minus y equal to 0. This is the relation. So 3x minus y equal to 0, or this implies y equal to 3x. Now you take x from A, then what happened? X equal to 1, y equal to 3, x equal to 2, y equal to 6, x equal to 3, y equal to 9, x equal to 4, y equal to 12. But when you will take x equal to 5, y equal to clearly 15, but that is not an element of A. Therefore, the order pair are x. Y order pairs are 1, 3. In the second case, that is 2, 3. In third case, that is 3, 9. And in fourth case, 4 and 12. Therefore, R equal to 1, 3, 2, 6, 3, 9 and 4, 12. Now represent this by Venn diagram. So this is the diagrams. So in this diagrams, that is 1, 3 this is, 2, 6 is this one, and 3, 9 is this one, and 4, 12 is this is. So clearly that 1, 1, 2, 2s are like this, 14 and 14 are not present in R. Therefore, R is not reflexive. Next, symmetric. H 1, 3 belongs to R, but 3, 1 is not belongs to R. So R is not symmetric. Third, transitive. H 1, 3 belongs to R, 3, 9 belongs to R, but 1, 9 is not elements of R. Therefore, R is not transitives. Clearly, so you see, 1 mass related way, so this is not reflexive. 2 mass related, this is not. Again, 1, 3 is present, but 3, 1 is not present, so it is not symmetric. Transitive, if 1, 3 is related, then 3, 9 is, but 1, 9 is not related, so it is not transitive. Next, question number 1, bit second. That is, R in the set of natural number n equal to 1, 2, 3 and so on. Define as R equal to x, y order pair such that y equal to x plus 5 and x is less than 4. So here x is less than 4 means x also belongs to here, x also belongs to n and y also belongs to n. H R is in the set A. So, and given x is less than 4, that means x equal to 1, 2, 3. So, when x equal to 1, y equal to 1 plus 5 equal to 6, the order pair is, the xy order pair is, that is 1 and 6. Similarly, when x equal to 2, y equal to 2 plus 5 equal to 6, this implies xy equal to 2 and 7. 2 and 7. Similarly, when x equal to 3, y equal to 3 plus 5 equal to 8, this implies x and y equal to 2, 3 and 8. So, r equal to 1, 6, 2, 7, 3, 8. Next we go to the diagram of this set, then we discuss one by one. You see here, the R relation contains 1, 6, 2, 7, 3, 8. So 1 is related with 6, 2 is related with 7, 3 is related with 8. Now we saw the reflexive. You know the reflexive property, the same is related with same. So 1 must be related with 1, but this element is not present here. So 1, 1, 2, 2, like all elements are not present in R. So R is not reflexive. Now come to symmetry. You take 1, 6, one of the example, but it is reverse. 6, 1 is not present in R. Similarly, you can say 2, 7 is present, but 2, 7, 2 is not present here. So likewise, R is not symmetric. Now go to the transitive. What is the transitive? AB belongs to R and BC belongs to. So that will start with same element. So 1 is n with 6 and second element must be with 6, but there is no such elements. There is no such element. Similarly, 2, 7, there is no such element which start with 6. There is no such element start with 6. You see here, no element start with 6. So, you can easily conclude that, from this that second element not present. So, you say this is transitive. R is transitive. When transitive, 1, 6 and something will be here, but there is no such element. So, likewise for all cases, it is transitive. So, R is, therefore, R is neither reflexive nor symmetric but transitive. Now we discuss the relation R in the set A, where A contains 1, 2, 3, 4, 5. Then define R as xy such that y divides x. This is the relation for the question 1 for third bit. Now x, y order pair such that y divides x. Y divides x. That means what will be the elements of R will be, you take the first y as a 1, then 1 divides what? 1, then 2, 1, then 3, 1, 4, 1, 5, 1, 6, 1, then 2 divides 2, 4, 2, 6, 2. Then 3 divides 3, then 6, 3. Now 4 divides 4, you see. There is no such other elements. Similarly, 5 divides 5. Then 6 divides 6. These are elements of set R. So all these elements are divided by 6, divided by 1. 1 divides the all elements, so 2, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1. Similarly, you take 2, 2 divides 2 itself, 4 and 6. So these are 3 elements. Then 3 divides 3 and 6. So this and this element. Again you take 4 itself 4. 5 itself 5. 6, 6. So these elements contains R. See here, the 1, 1, 2, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1 are related. So see, 1, 1, 2, 1, 3, 1, 4 1 5 1 6. Similarly 2 2 4 2 6 2, 2 2 4 2 6 2, then 3 3 6 3, 3 3 and 6 3, and 4 4 4 4, then 5 5 5 5, this is, then 6 6. So this is the Venn diagrams of this relation R. Now you have to show reflexive. Reflexive, clearly 1 1, 2 2, 3 3, 4 4, 5 5, 6 6 are present in R. This implies R is reflexive. Then symmetric. See here, 6 1 is present here, but 1 6 is not present here. This implies R is not symmetric. Similarly, then reflexive, then transitive. See here, 1 1, there is no element started with 1, so it is clearly transitive. Then you go to 2 1, there is no element started with 2 1, so clearly 1 1, 2 1, like this, 6 1 are transitive. Then come to 2 2 belongs to R, 2 1 belongs to R. This implies 2 1 belongs to R. So you see here 2 2, and it started with 2, so it is automatically transitive. Similarly, you take 4 2, also same, 2 1 belongs to R, implies 2 1 belongs to R. Likewise, you take 6 2, same, then take 3 3, 3 3 belongs to R, then 3 1 belongs to R. So this implies 3 1 belongs to R. So transitive, transitive, transitive. Now you take any elements like this up to say 6 6 belongs to R, 6 1 belongs to R. This implies 6 1 belongs to R. So in all cases, the second element of the first order pair and first element are same, then you have to show these two. These two. So these two belongs to order. So it is clearly R is transitive. Therefore, R is reflexive and transitive. Reflexive and transitive, but not symmetric. Question number 1 IV. The relation R in the set Z is defined by R equal to xy order pair such that x minus y is a integers. That is, xy belongs to Z, then x minus y belongs to R if x minus y belongs to Z. This is the questions. Then you have to show this is reflexive, symmetric or transitive. For reflexives, so you see x is related with x, so let x belongs to Z, x belongs to Z, then x minus x equal to 0, which is belongs to Z. This implies x order pair belongs to R. So R is reflexive. Now show that symmetric. It is also very simple. That is, let x and y order pair belongs to R. This implies x minus y is an integer. Is an integer. Then this implies y minus x is also integer. That means yx order pair belongs to R. So xy belongs to R. This implies yx belongs to R. Xy belongs to R. So yx belongs to R. This implies R is symmetric. Very simple. Next we discuss transitive properties. If xy belongs to R and yz belongs to R, then you have to show xz belongs to R. This is the transitive. Since xy belongs to R and yz belongs to R, xy belongs to R means x minus y is an integer and y minus z is an integer. Now you take the sum of these two. Sum of two integer is also integer. Then x minus y plus y minus z is an integer. Then this cancel. That is x minus z is an integer. This implies xz belongs to R. This implies R is a transitive. This implies R is reflexive, symmetric and transitive. Now question 1, section B. R is defined in the set A, where A equal to the set of people in a city. In a city or in a town. This is. Now A, you have to show that R is a relation, that is x and y order pair such that x, y work at the same place. X and y work in same place. This is. Then you say x and y. Now we have to show reflexive. Reflexive means x and x work in same place. Same place, clear? Same x is here. That means R is reflexive. Then symmetric. It is also very easy. That is, let xy belongs to R. Implies x and y work in same place. That means y and x also work in same place. That means y x order pair belongs to R. This implies R is symmetric. You see here, x y order pair belongs to R. They are living in the same, working in same place. In reverse also working in same place. So x y belongs to R. That is y x belongs to R. That means R is symmetric. The next property is your transitive. So in transitive, we have to show if x y order pair belongs to R and y z belongs to R, then we have to show x z. Second relation, then we have to show the first and third. Okay. Then you see from this, x and y work in same place. Similarly, from this, y and z were in same place. This implies x, y and z were in same place. This implies x and z were in same place. This implies x, z order pair belongs to R. So R is transitive. Therefore, what happened? Therefore, R is reflexive, symmetric and transitive. This is. Next question 1b, section B. xy such that x, y live in the same place. This is same as bit A. X and y work in same place, live in same place. So you same way you start as A. That is reflexive, symmetric and transitive. Same way you discuss. There is nothing else. Just you write in plus or live, in plus what you write just live. Then that will equal with the same A. Now you see in section C, R, X, Y order pair present in R if X is exactly 7 cm taller than Y. That means X is 7 cm taller, means X equal to Y plus 7. Then XY belongs to R. Or you can take this to this side, then X minus Y equals 7, then XY belongs to R. Now we have to show reflexive. We know that x minus x is 0, which is not 7. So xs is not an element of the relation R. So R is not reflexive. Now you have to show the symmetric properties. In symmetric property, if xy belongs to R, then you have to show yx belongs to R. Now you see x minus y, let xy belongs to R. That means x minus y is 7. Now you take y minus x minus, which is not equal to 7. So yx order pair is not present in R. So R is not symmetric. Very simple thing. X minus y equal to 7, then y minus 7. So it is not an element of R. So R is not symmetric. Now we have to show the transitive properties. That if xy order pair belongs to R, yz order pair belongs to R, then you saw that xz order pair belongs to R. So let xy order pair belongs to R and yz order pair belongs to R. That means x minus y equal to 7 and y minus z equal to 7. Now add these two. What happened? X minus y plus y minus z equal to 7 plus 7, that is x minus z, that cancels. So x minus z equal to 14, which is not equal to 7. So this implies x, y, x, z order pair is not an element of R. That means R is not transitive. So we discussed that R is not reflexive, not symmetric, not transitive. Next about the D. In D are x, y order pair such that x is a wife of y. So x order pair is present if x is a wife of y. Now you see here for reflexive. x is not wife of x, so clearly x's order pair is not present, so R is not reflexive. X is never wife of x, so it is clearly that R is not. Now in case symmetry, let xy belongs to R, then we have to show y x belongs to R. That means what happened? Now x is wife of y, but you see y is not wife of x. That means yx order pair is not belongs to R. That means R is not symmetric. Clear. Next we have to show transitive properties. So in transitive, if xy order pair belongs to R and yz belongs to R, then xz belongs to R. Now if this happens, then what happens? X is wife of y, but y never be a wife of anyone, because x is a wife of y, then y is a male, so male will never be a wife of this. So automatically we cannot show these properties, so there is no need to show this. So automatically R is transitive. This implies R is neither reflexive nor symmetric, but it is a transitive. Thank you. Now we discuss about the E section. R is a relation. The order pair xy belongs to this R if x is a father of y. Then you have to show the reflexive. So reflexive, you see x is not a father of x, so x order pair is not an element of this. So R is not reflexive. Because x is not a father of x, so xx order pair is not present in R, so it is not reflexive. Now come to symmetric. In case symmetric, let xy order pair, then x is a father of y, but y is not father of x. Y may be son or daughter of x, so this implies yx order pair is not an element of R. This implies R is not symmetric. This question is same as question number D. This is same as D. How you follow in D, same way you follow in this section. Now we have to show the transitive properties. So in transitive properties, if xy belongs to R and yz belongs to R, then you have to show this one, xz. The second element equal to second, then you have to show this and this R belong to this set. If this, that means x is a father of y. Now y is a son of this, then we proceed. If daughter, then it is automatically transitive. Then if y is a father of z, then what happened? X is not a father of z, x is a grandfather of z, x is a grandfather of, so xz is not an element of R. That means R is not transitive, therefore R is neither reflexive nor symmetric nor transitive. Kindly subscribe the channel.